In this video, we are going to learn about how to create a schematic symbol and PCB footprint for RGB LED in SMD package. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding the datasheet and understanding how SMD package of RGB LED looks like. Second step is to creating a schematic symbol using EasyEDA, understanding the representation of RGB LEDs as per the datasheet information. Third step is to understand and create a PCB footprint of a SMD package of RGB LED with the IPC standards and Cartesian geometry. Last but not the least, fourth step is to combining a PCB footprint and a schematic symbol to form a component library. So let's get started. Now we have a datasheet from Vishay Semiconductors, which is a leading manufacturer of various electronic components in India and across the world. So in this particular datasheet, they have mentioned on the top side, it is not for new designs, which is essentially means, which is so-called NRND in most of the development area, called not recommended for new design, which means you should not use this component for the new design activity. Why? Because they might have stopped manufacturing this product, or they might have changed the product dimensions or datasheet information as per the requirement to the new era of industry. So that's why this recommended or this non-recommended datasheet I am using for this tutorial, because it is easy for understanding and it is absolutely same as a new product that is from Vishay Semiconductors. So whenever you are using this kind of a datasheet, make sure that whether the component is NRND or no active, or it is available in market or not. Because once you design the PCBs, it is very difficult to change everything from a datasheet or from design activity or from even a component library level. For learning purpose, we can use this particular datasheet and understand how to design a RGB LED in SMD package. For that, I'll scroll a little bit down to understand a little bit information about this particular component, which is required for our component library design. First thing is, we need to know the part number, because that is absolutely necessary part for the entire design activity. This part stands for VLM RGB 612200GS08. This is a part number given from the manufacturer, so we have to follow that particular part number and search that particular part number on any supplier website like Moser India, DigiKey, Arrows, Element 14, wherever you feel comfortable, or from wherever you are procuring the component. So on Moser, you can see that this part is available, and it is available in stock with a very minimal quantity, but still at the point of this video recording, I can see 511 components are available, and pretty much the factory lead time is 12 weeks, which is very long. Still we can consider and go ahead with the design activity. The most important thing is the package is SMD version. As we said from the 11th tutorial of this tutorial series, we are using the SMD footprint design rather than just going with a through-hole one. Through-hole RGB LED is the first LED or first component library that we have designed in this entire tutorial series. That's why we are going with the SMD one. And SMD package is SMD PLCC6. The way how we have a dual inline package, single outline package, or SOIC and SO output package, small outline plastic inline package. So different types of packages are available in with respect to the PCB footprints. The same way, PLCC6 is also a type of package specific for LEDs, LED bodies we call them. And if we want a forward voltage and a maximum forward current, or a forward current for this particular LED series, is available on this datasheet. Based on this only, we will design the circuitry and the resistors used for this LED driving. But we are not interested in that, so we'll be scrolling a little bit down to get to know that what is the dimension or a mechanical details about this particular LED. A schematic symbolical representation is little different, because they have a true green color LED and other two are derived LEDs. What is that and why we are having a true LED and non-true LED, that is a little bit technical one, which I'm not going to cover in this tutorial. But you can see that we can literally design this RGB LED schematic symbol as same as our first tutorial, which deals with a through-hole component. But right now we have a different cathode and different anode for each LEDs. That's why I'm going to design this entire package once again. wherein we can see the data information with respect to mechanical dimensions, which is very important and very minute in size. A very tiny LED it is, but it does a lot of good things and makes a lot of sense with respect to component which are less than 10 mm by 10 mm or something like that. Okay, so we can have a body height of the LED as a 2.8 mm, and width of the entire LED body is going to be 3.2 mm, wherein the pitch of each pin is going to be 0.85 mm, and width or height of the entire pad, a single LED pin ka pad, is going to be 0.55 mm. What about the width of that particular pad? It's again choice to the designer, but still in this particular data sheet we can see the recommended pad design pattern. In this recommended pad design, you can see that 1.7 mm is the minimum distance between one edge of the pad, left side pad, to the one edge of the right side pad. A minimum distance. You can see here the arrows are indicating where it is. And what is the maximum distance from the extended edge of the pad to the extended edge of the pad on either side is going to be 4.2. So what we are going to do is we are going to open a calculator quickly and try to compute the width of the pad by using these two dimensions. How do we do that? We are going to reduce 4.2 with a 1.7. So 4.2 minus 1.7 is going to be one number. And if we divide this one by 2, we will get to know the width of each pad. Why we are dividing by 2? Because we have one pad here, one pad here. If we minus the longest distance with the smallest distance, we'll get the distance this plus this one. So if we divide it by 2, then we will get the one particular pad ka width. This is how you need to compute the dimensions sometimes if it is not available directly on the data sheet. By using these informations, whatever we discussed so far, we are going to design a footprint of this particular LED. However, schematic symbol is going to be the straightforward one, but one important thing is we do not have common cathode or common anode here. All LEDs are individually driven, so all LEDs cathodes are different, all LEDs anodes are different. Keeping this in mind, we'll head towards the next procedure. Now I am in front of a EasyEDA. Here I am going to design a schematic symbol for this particular RGB LED as we did for the last 11 tutorials. So let's do it. Alright, now we are done with creating a schematic symbol in EasyEDA. Make sure that while saving the entire schematic symbol, you give a prefix as LED ? Because it is not treated as an integrated circuit, because it comes under a luminous components, which is all about LED. That's why make sure that you give a prefix as LED ? And other than that, for this particular tutorial purpose, I have referred a Moser part number, Moser supplier part number, manufacturer part number and all that detail. But it is not limited to Moser only. Whichever supplier you are using, you can select that particular part number in this entire library design. So once we are done with the schematic symbol design, next step is to go for creating a PCB footprint according to the datasheet information that we just now discussed. But one important thing, this schematic symbol doesn't look symmetric. If it is possible for you to make it symmetric, then please do try that. Because of recording time constraint, I have done it whatever best possible in this short duration. And giving a color to each LED will make them look like a RGB LED, true RGB LED, rather than making them a normal LED and giving a R LED, G LED, B LED naming at the edge of the LED. So give a try with the different ways of representing a RGB LED in this schematic symbol. Now let's start with the PCB footprint as we do all the time. Now you can see that I have completed creating a PCB footprint for PLCC6 package, which is RGB LED package as indicated on the manufacturer datasheet. As per the dimensions, we tried our level best to make this entire footprint. But if you feel anything to be improved in this design, please feel free to do that and let me know your thought process in comment section. Now we are done with the PCB footprint. Next step is to combine this footprint with the schematic symbol that we have designed and create a component library. For creating a component library, I'll be heading towards the schematic symbol that I have designed, and in that I'll click on the footprint option. Here I will search for PLCC6 package, which is just now designed, and once I click on that, you can see that all the pins are aligned with the schematic symbol that I have designed. Once we can see all the things are aligning, then I can click on update footprint. Once we are done with updating a footprint, just cross verify whether everything is fit perfectly or not. by using a simple schematic example. For that, I'll go to the file and I'll go and create a new schematic window. Here I'll go for the libraries, and here I'll search for RGB SMD LED, which is just now created. So we have RGB SMD LED. This one is an old one, so I think we have to select this one. Yes, this one. So I'll just place it on the schematic window, and you can see here the entire schematic library is created. Schematic or component library, you can say. Because when I click on that library, and you can see that all the details that we have updated while creating a component library is visible to us. This is how you create a schematic symbol and PCB footprint for RGB SMD LED. I believe you have learned something new in this tutorial and tried designing a schematic symbol and PCB footprint with the SMD architecture of RGB LED. If you have any questions, suggestions, or any comments, let me know in the comment section below. Thank you so much for watching this tutorial. See you again in the next video. Until then, tune yourself to make a difference.